Today we'll be learning about the remainder theorem, which uses long and synthetic division. Do you remember long division from middle school? Let's check by dividing 247 by 7. Your first thought should be, does 7 go into 2? Since it doesn't, I move to the next set of numbers. Does 7 go into 24? The answer is yes. 7 goes into 24 3 times. So I multiply 3 times 7 to get 21. And then I subtract this. 24 minus 21 gives me 3. We bring down the 7. Now I need to think, how many times does 7 go into 37? Well, it goes into it 5 times. 7 times 5 is 35. So I put 35 down, and we're subtracting. I have 2 left over. 7 cannot go into 2, so 2 would be my remainder. So your answer is 35 with a remainder of 2. Now we're going to use the same idea to divide any two types of polynomials. Your first step for using long we're going to go through the steps at the same time as we go through example 1. So step 1 is put the problem in standard form and insert 0 for any missing terms. So for example, this first one is missing an x squared term. So we want to make sure that we insert a 0x squared to act as a placeholder for us. Then we're going to set up our problem. X squared minus 2x plus 2 is your divisor, so it goes outside. And then under the hunt is your dividend, where you have 2x to the 4th plus 3x cubed plus 0x squared that we added in plus 5x minus 1. Step 3 says to look at the first terms and think what value times the divisor's first term equals the dividend's first term. So x squared times what gets me 2x to the 4th. The answer would be 2x squared. Step 4 is to put that number up top. Then I'm going to multiply that value by the divisor and put it underneath. So I'm going to take 2x squared, multiply it by all 3 of these terms, and line it up underneath. So I get 2x to the 4th minus 4x cubed plus 4x squared. Step 5 then has you subtract the polynomials, but be careful because we have to just remember to distribute the negative. So it may be easier to think of it as changing all of the signs. Then we're going to add them together. So your first term should add to 0. We then get 7x cubed minus 4x squared. We're going to bring down the next term of the dividend, and we're going to start again. This time I have to think x squared times what number gives me 7x cubed. The answer would be 7x. So I'm going to put it up top, and then I'm going to multiply it by the 3 terms out front. We get 7x cubed minus 14x squared plus 14x. I'm going to make sure that I go through and switch all of the signs. Then we're going to add it together. The first terms add to 0, so we're left with 10x squared minus 9x. Then I'm going to bring down the next term, which was a negative 1. And we're going to start our process over again here. This time I'm thinking x squared times what number will get me 10x squared. and that would be just 10. So I'm going to take 10 and multiply by the 3 terms out front. I get 10x squared minus 20x plus 20. I'm going to flip all of the signs and add these together. I get 11x minus 21. I cannot multiply x squared by anything to get 11x, therefore we know we're done with the problem. Your answer is going to be written as 2x squared plus 7x plus 10, and your remainder gets added on in the form of a fraction. So we have 11x minus 21 in the numerator, and then the polynomial that you were dividing by in the denominator. So x squared minus 2x plus 2. Right? Let's take a look at completing example 2. We want to make note that we are again missing the x squared term, so we'll have to replace that with a 0 when we set up our problem. So on the outside we get x cubed plus x squared plus 0x minus 5, and underneath I get 2x to the 4th plus 2x cubed plus 0x squared minus 10x minus 9. And we're starting with x cubed times what gives me 2x to the 4th. My answer would be 2x, so I'm going to put that up top and then multiply the 4 terms by 2x. I get 2x to the 4th plus 2x cubed plus 0x squared minus 10x. I'm then going to go through and change all of the signs and add these together. The x to the 4ths add to 0, the x to the cubes add to 0, x squared adds to 0, and x adds to 0, which means I bring down my next term, which is the negative 9. I can't multiply x cubed by anything to get negative 9, which means we're done. Our answer is 2x plus negative 9 over x cubed plus x squared minus 5. Please flip the paper over and look at the next side. On this side, we're going to be looking at using synthetic division. Do you remember synthetic substitution, where we put the 2 out front and set up the coefficients? So I have 3. I need a 0 for the x cubed as the placeholder, a 0 as the x squared, 2 for the x, and then negative 4. And we bring down the first term, so we get 3. 2 times 3 gives us 6. 0 plus 6 gives us 6. 2 times 6 gives us 12. And we continue this pattern where we multiply and then add, and multiply and then add. And our last term here gave us our answer. So we could say that f of 2 was equal to 48. We're going to use the same idea to divide polynomials. The only caveat is that you can only divide by a linear polynomial. Here are the steps for synthetic division, and it takes you through an example down below. So first we're going to put the problem in standard form and insert zeros for the missing terms. You're going to set up your problem by putting the divisor out front after it's been solved for x. So for example, we would set x minus 2 equal to 0. And when we solve, we find x equals 2. This is the number that goes out front. You are then going to put all of the coefficients up top of the bar. So I have the 1 for the x cubed, 2 for the x squared, negative 6 for x, and negative 9 for my constants. You want to leave a space here at the bottom to add in some numbers. Then you are going to bring down the first number below the bar. You're then going to take that number like before, multiply it by on the outside, put in the next column, add them together. So these first steps here are the same as our synthetic substitution. However, it changes when we talk about the answer. The final line represents the coefficients of the quotient. You're going to start the first term 1 degree less than the first term of the dividend. So if I start it with an x squared or an x cubed, my answer is going to start with an x squared. So I get 1x squared plus 4x plus 2, and negative 5 makes up my remainder, again written as a fraction. Let's look at this with example 3. Alright, if I set x minus 2 equal to 0 and solve, we get a positive 2 on the outside. So I'm going to list my coefficients up top, making sure that I use a 0 in place of the x squared that's missing. And I'm going to bring down the first term. 2 times 1 gives me 2, so I put it in the next column, bring that down, then I'm going to multiply and add, multiply and add. Because my original problem started with a degree of 3, my answer is going to start with a degree of 2. So I get 1x squared plus 2x minus 3 plus my remainder, which is negative 12, over the divisor, which is x minus 2. And that gives us our final answer. Let's look at one more together. You can pause the video if you want to try it on your own. If you set x plus 2 equal to 0 and solve, we find that x is equal to negative 2, so that's the number that goes out front. Our coefficients are 3. We need a 0 for the x cubed and for the x squared. And then we get 2 and negative 4. I'm going to bring down the first number, multiply out front, add it together, multiply, add together, multiply, add together, and I'm going to continue this pattern till I get all the way at the end and get a remainder of 40. Because the original problem started as a degree of 4, my answer is going to start with a degree of 3. So 3x cubed minus 6x squared plus 12x minus 22 plus my remainder, which is 40, over my divisor, which is x plus 2. We will go over more examples tomorrow in class.